Hi class, today we're looking at lesson 3-4, ratios and rates, as well as solving proportions. There's a bit of vocabulary at the beginning here, so take your time, make sure you have all of your notes filled in, and you can understand the difference between a ratio, a rate, and then also use proportions. First, we're going to talk about cross products of a proportion. If you look here, if you have A over B equals C over D, and we cross multiply, so we're going to multiply the D and the A, and the B and the C, we're left with A times D equals C times B. Here's an example. We have 2/3 equals 8/12. So 2 times 12 should equal 8 and times 3. And we get 24 on both sides, so we know that's true. Moving on to ratio is a comparison of two numbers by division. A rate is two quantities of a ratio that are of different units, then the ratio is a rate. Okay, so if you're like miles per hour, feet per second, that would be a rate. A unit rate is when you have a denominator of 1. A unit analysis is the process of converting one unit to another. This is also sometimes called factor label method, and I'll show you an example of that. We have a proportion is an equation that states two ratios are equal. Basically, two fractions are equal. We have proportions, so we have the extremes of our proportion are A and D, and the means are B and C. And the cross products are A times D equals B times C. So let's look at a unit rate. If we're buying grapefruit juice and it costs $1.56 for 48 ounces, to find the unit rate, remember unit rate has a denominator of 1, we're going to find out how much it costs for 1 ounce. So we write the proportion 156 divided by 48 ounces. If we do the division here, okay, remember fractions are just division problems. A lot of you ask, where's the fraction button on my calculator? There isn't one. You have to understand that fractions are just divisions. It's just an operation of division. And we end up getting, when we divide, we end up getting dollars per ounce. And this is 1 ounce. So it's about 3 cents for 1 ounce. Moving on to example 2. We have Lance Armstrong completed the 3,630 kilometer trip of the Tour de France in 92.5 hours. Traveling at his average speed, how long would it take him to ride 295 kilometers? So if you let t be the time needed to ride the 295, and we have our average speed, okay? So to get our average speed, we're going to take the total miles over the total hours, and that should equal the miles over the hours of our smaller trip. So we can cross multiply here. So we take the 3,630, multiply it by x, and set that equal to the 295 times the 92.5. We compute, divide by 3,630 to solve for x, and we should get about 7.5 hours. Please take the time to write those steps down, get out your calculator, double check the math. Okay, we've got a quick check here. Go ahead, take a minute, see if you can compare the florists and find out which one has a better unit rate. And then go ahead and reveal the answers when you're ready. Main Street is $1.03 per rose, while Flowers for You is $1.25. So Main Street is actually better. Moving on to example 4. We're solving this proportion here. Okay. First thing, these are both z's. We have z plus 3 over 4 equals z minus 4 over 6. Okay, now we can assume anytime you have a fraction written this way, the entire numerator is in parentheses. So you want to kind of place some parentheses around there in your notebook. And then we're going to cross multiply. So we're going to multiply this 6 times this entire parenthesis here, and the 4 times the entire parenthesis here. Notice how I have it written, 6 times the parenthesis or times the quantity, z plus 3 equals 4 times the quantity z minus 4. So we're going to use a distributive property here. And we get 6z plus 18 equals 42 minus 4z, excuse me, not 42. See why we shouldn't use z's? 4z minus 16. And then we can subtract 42 from both sides. And we're left, or excuse me, 4z, did it again, 4z from both sides, and we're left with 2z plus 18 equals negative 16. Subtract 18 from both sides, and we're left with 2z equals negative 34. Divide both sides by 2, and we're left with z equals negative 17. Go ahead and take a minute, go through those steps, make sure you understand why we're able to do all of those steps. Moving on to conversion, or what I like to call factor label. Let's look here. We have the fastest kangaroo is the eastern gray kangaroo. It travels at 40 miles per hour. So 40 miles, 1 hour. Here we go. We want to know the kangaroo speed in feet per second. Okay? So feet per second. So the first thing we're going to do is we're going to convert our miles into feet. So you might want to get out your PSSA formula sheet. There's lots of conversions on that sheet for you. But when we look at that, we find that there are 5,280 feet in 1 mile. So why do we multiply it by this fraction rather than the 1 mile over the 5,280 feet? Well, if you look here, our units are going to cancel out. If you have miles divided by miles, excuse me, miles divided by miles, you get 1. Multiplying divided by 1 does nothing. So our miles are going to cancel out, and now we have feet per hour. So now we need to take care of those hours and convert those to seconds. So our next conversion is going to be 1 over 60 minutes, 1 hour. And I put the 1 hour in the numerator because it's in the denominator here to start with. So this will cancel out, as well as this hour will cancel out. And we are dividing by 60. Okay, but this is 60 minutes. Now we want 60, or we want per second. We want our unit rate to be per second. So then the next thing is we have to cancel out minutes. And if we use the conversion, 1 minute equals 60 seconds, okay, we can divide our minutes out, and we're left with seconds in our denominator. So we have feet per second. If you look at our answer here, it's feet per second. So then we can just go multiply through with our calculator, take 40 times the 5,280 and divide that by 60 and 60 again, okay? The whole reason we can do these unit rates here is because these are equivalent. 5,280 feet is like saying it's a mile. It is a mile. And if you have anything divided by itself, guess what this becomes? 1. And you can multiply 1 by 1 anytime you want, and it's not going to change the value. It might change the appearance of your fraction, but it's not going to change how the value of it, okay? It's going to change the appearance a little bit. In this case, we've converted our miles per hour to feet per second, okay? This is probably one of the most complicated procedures in this unit. There are some sample questions we will do in class, but please make sure you have a grasp on converting rates. This will also help you in science class a great deal. All right, moving on. We are looking at quick checks here. Go ahead and complete the quick checks. When you're ready, you can check your answers. If we're walking 2 miles in 35 minutes, our average speed here is going to be distance equals rate times time. Okay, and our rate is 0.057, which if we calculate it miles per hour, it is 3.43 miles per hour, okay? We have a sloth that's traveling at 0.15 miles per hour. So we have the 0.15 miles per hour. So the first thing I'm going to do is multiply by 1 hour over 60 minutes. So now I'm left with my hours cancel out, and I've got miles per minute. I then get rid of my miles by multiplying it by feet per mile. Notice my miles are going to cancel out, and I'm left with feet per minute, which is 13.2. Solving the last few proportions here. Number 4, x equals 5. Letter B, y equals negative 8.75, or 8 3/4. And C, w equals negative 21. If you have any questions, please bring them to class tomorrow. Thank you.